About myself, I am a director of engineering at Aptus. I mostly work on modern architecture, that's my passion. I don't get the time to implement that much with clients because they are always susceptible about new things. But I go to meetups and talk about that. I can be reached at LinkedIn and I have a Twitter account, not updated that much, but I plan to do that. So in terms of agenda for today, we will look into serverless or function as a service. We will see what are the support that is available in Azure. Means it's a vast topic, but we will focus only on Azure for now. And we will have a demo application. So we will see how it works in Azure ecosystem, how it is implemented, what kind of tooling is available. Even though this is an architecture session, I like to go deep in the technology and do an end-to-end thing. So, most of you have heard about it. Do you think it's a hype or it's a reality? Hype?
Not sure.
Okay. Okay, there are no gray areas in computer science, there are only zeros and ones, right? Okay, so let's see, it's a hype. Okay, let's start assuming that it's a hype because there's so many things which is happening. So for example, Gartner has said that by 2022, it will overtake platform as a service. So if you worked in Azure ecosystem, if you worked in cloud, that's a big statement, right? All the vendors are pushing for PaaS, and here it was somebody saying that it will overtake PaaS. And it goes on to say that rendering the cloud platform architecture dominating it as a legacy. So basically what you're learning now about cloud architecture is everything going to become legacy. We talked about exponential, I don't know what it is. I think this is exponential. Some more hype. But 2020, most of the cloud vendors will self-disrupt. Okay? And examples of self-disruption is AWS Lambda, which is function as a service. They are the pioneer in this. Everybody is catching up. So they will self-disrupt. Now, some more hype. We have conferences coming up which focus solely on serverless. Right? One is coming in Bangalore. I am the speaker, so I will not go there. Okay? But it has been happening all over the world. It is happening in most of the major cities, and the serverless conference which happens in New York, they will be doing it second year this time. So there is a lot of hype. Everybody is talking about it. Let's do a reality check. Okay? In reality, it is supported by all cloud vendors. When I say all, means with the top 5 they all support it. AWS Lambda, they are the pioneer in this. They started it like 6-7 years back, and they have been constantly improving on that. I may not be sure on the fact that they started 7 years back or not, but they started long back. They were the first to implement it, and they provided awesome support for that. Then we have Google Functions. We have Azure Functions, which we will explore today. And then we have Oracle Functions. Oracle announced 2nd October, almost like 3 days back. They announced it in Oracle Cloud. Okay? And they are saying that all you need is a Docker image, and we will provide an abstraction layer. Wherever the Docker image runs, you can run your functions. And then you have Apache OpenWhisk, which is an open source project. And that open source project is backed by IBM. Okay? So there is a lot of ground support that is there. So it's more than a hype. It does have a bright future. So a lot of you have questions about job security and all. So if you want to secure your job, at least for next 4 years, this is a good thing to learn. Okay? Let's see what are the drivers of that. So I have been in architecture for almost like 16, 17 years now. And I started with, something called code bar. How many of you have heard of it, code bar? Lot of it, right? It started with it was a shining example, client-server architecture. More than that, you have to do a lot of plumbing. Then come Java J2E-based architecture. It changed everything, right? Java was the platform. You have a lot of abstraction on top of it. You can connect to any database. You can connect to any messaging services. You can do distributed transactions and a lot of things, right? Then comes service-oriented architecture, which kind of replaced multi-tier architecture with much more packaging, everything revolving around functions, not function, everything revolving around services. And then came microservices, which took it to the next level, made things more, modular, and with the support of Docker, you can do a lot more. Now what is happening is, we are into API-driven economy. Everything is an API, everything is a service. So we saw a diagram in image of Wells Fargo, right? And so many people trying to complete a small piece of Wells Fargo, right? So how they were doing it? They were doing it through APIs, right? You have API for everything. In fact, there are some services like Zapier, all they do is from the browser you can do integration. You can integrate with accounting software, you can integrate with configure software, pricing software, quoting software, invoicing software. They just do one thing and they do it pretty well. No more writing things from the ground up. So we are in a API-driven economy, and even authentication, which is supposed to be non-functional requirement, is available as a service, right? You use Auth0. If you want database as a service, you use CosmoDB. There are many means. I have put just one example, but every vendor has something. Even machine learning, which was like 3 years back, was like only in the domain of PhDs, is democratized. Anybody can use it. If you have not used Azure machine learning, you will find that you try using that. It's very simple. All drag and drop. In fact, you can build a recommendation service in like 30 minutes. And I'm not joking. It's all drag and drop from the browser. All you need is the data. And in fact, you can create a data in a spreadsheet and upload it. So it's so powerful. And then you have a backend as a service. Backend as a service means if you're building an Azure mobile, if you're building a mobile application, then Google has something called Firebase, and then there is open source. We have Parser, which is backed by Facebook. So you can quickly build a mobile application. When I say quickly, maybe in 2 weeks you can build an entire application. So when you have all those things, you don't actually have to write things from the scratch. What you want to do is you just want to integrate all of them and build an application out of it. Right? So that is leading to point number 2. That you develop apps faster and you focus only on the logic. Non-functional requirements are taken care of by someone. Okay. Third thing is optimal utilization of resource. You are integrating all those services, you are building it. Now you want to deploy it. When you deploy it, you want on the same machine, you want to have 100% utilization of that machine. Right? You want to utilize those resources properly. And one of the reasons why people are moving to the cloud is because of the optimal resource utilization. It's a shared resource, right? On the same machine, on the same VM or same piece of hardware, you can install multiple things. Okay? It avoids idle capacity, and metering is tied to the usage. And you use the VM, you don't like it, you shut it down. And that's what Docker also does. Docker has taken things to the next level. You can put a lot more on the same machine, condense it further, and have a better utilization. So these are the drivers. Now these drivers are leading to the serverless. So what exactly is the definition? Everybody has their own viewpoint. If you ask an infrastructure guy, he will give you a different viewpoint. If you ask a developer, he will give you a different viewpoint. If you ask an architect, he will give a different viewpoint. Okay? So I took a stab at it and came up with my definition. You don't have to agree with it, but this is just my opinion. A software architecture, basically it's a software architecture that is creating auto-scaling application, self-managed application that are built based on execution. Right? Auto-scaling, self-managed, and building based on execution. I talked about there are many architecture patterns, right? We engineers like to invent things. Every 5 years we come up with something new. Not even 5 years, maybe in 2 years we come up with something new. You must have heard about service-oriented microservices, which are the latest trend, that they have come up with last 4 years. The common thing about them was they did not talk about the cost optimization. They were more focused on how to do things, how to package it, how to integrate it, how to expose it, how to authenticate it. Something goes wrong, what to do with it. They did not talk about the cost optimization. They say it is implicit. You do it, it will be taken care in the end. Right? This is the first architecture where the cost is built into it. When you say I am using function as a service, people assume that it will be optimized. I don't have to pay for the ideal time when it is not running. Right? How many of you have done capacity planning in their life? The whole idea of the capacity planning was to optimal, right? Developers build something, give it to you, you run many test cases, you say, okay, if there are so many users, we need this much hardware. If there are so many users, we will need this much hardware. If it is sale or something, we will need this many hardware. It's such a big exercise. Right? The focus was on meeting the non-functional requirement and cost optimization. You don't want to just throw hardware at it. So this is one of the architecture which talks about cost optimization. It is built in the definition. So if you go to Azure function, Google function, Lambda, they all say run it, you will charge. It is optimized for the cost. You don't have to pay extra for it. But having said that, is it innovative or disruptive? What do you guys think? Innovative or disruptive?
Disruptive.
I think it is disruptive. Again 0 and 1. We don't have grade. There is no 0.5 in computer science. I think it is disruptive.
Why? It is innovatively disruptive.
Yeah, means if you want to play with words, you can play with words. But yes, it is disruptive. Why I think it is disruptive is because of the cost factor. How many of you know about an Australian census website which went down within first hour of going live? So IBM paid. So in Australia they paid a lot of money to IBM saying that we will put all the population data on the servers. Okay? So they digitalized everything. So entire population of Australia was, they were categorized and all those things, and they were put on the servers. And IBM was the vendor. They took 3 years, millions of dollars, built a website. If somebody logged in, the very first day of going live, the website crashed. It happens, right? Life is not perfect. IBM said, oh, there's so much data, it was expected, we didn't do capacity planning. Next, somewhere in Australia there was some hackathon happening. 3 guys built it, the same data, they put it in a spreadsheet, they created a giant spreadsheet, built everything, and put it live. And they said, this is the data we are putting, it will not go down. On a sum of $500. And the site did not went down. Why? Because it was running on AWS Lambda. So it's a great case study on what disruption can do. Because these guys were running on AWS proven platform. They could have run it on Google also or Azure also, I'm pretty sure it would have scaled. But for Amazon it was like, okay, Australian population is how much? 20 million people or less than that, something in that range. Millions of rows are not a matter for us. We handle billions and trillions of rows. So that's the power. It's a great case study, so it makes it disruptive. That was the first thing that brought to everybody notice the power of serverless, the power of managed server, the power of cloud. Okay, so it was a big definition, so let's break it down. What does it mean for us? What does it mean for the architects? Right? First thing is no management of server, no patches, less DevOps. I know there are a lot of DevOps guys, they will hate it, but that's the reality. When somebody moved their less DevOps, no patches. How many of you have heard of Experian site getting hacked? Why did it got hacked?
Somebody didn't patch.
Somebody didn't patch.
It was Equifax.
Huh?
Equifax.
Yeah, sorry, Equifax. Somebody didn't patch. And what is that they didn't patch?
Struts.
Yes. They were running an older version of Apache Struts. In fact, it was not Struts, they were using an XML library in Struts, which was very old. So, those guys didn't patch. The Struts guy didn't patch. XML libraries, so everybody was pointing. And the XML libraries guys were saying, we are open source guys. Okay? You have a problem, go and fix it. So, here, in this architecture, there is no concept of patch. Means it can happen, but you can always blame AWS or Google. It can happen, right? AWS may forget to patch something. It could have well happened in a AWS. AWS does not support Struts, but it does support Springs and all, right? It's Spring Boot, it's based on Spring Boot. So it may happen that Spring did not patch any something and it went down. Okay? It auto scales. So all the guys who are doing capacity planning means, they will be disruptive. They will be disrupted because it auto scales. Underline there is still containers and all those things, but it auto scales. You don't have to worry about it. There is a guarantee that it will scale. And so what does it mean for the end user? They will not get a server busy issues. I just wish IRCTC was running on these things. Right? Provide us skills applications and no capacity planning. Again, the third advantage is cost model based on per execution. It's very difficult to say what is the running cost of this software. You build a great example, you build a great website and all those things. What was the running cost? For example, you're playing this game, right? How much that website would have, how much it would have costed that website to host 34 people and run how many visitors were 10, right? So how many requests went there? 340? Something of that order, right? And we played it for how much? 30 minutes? Less than that, maybe 10 minutes. We actually used the server for 3,400 minutes. Right? Assume that if somebody said that if you use my server, so this is, on this, the cost model is how many users, how long did you use it? How much memory did you use? So based on those factors, you will do the cost modeling. So you know upfront how much it is going to cost. So the capacity planning is about how many users are going to come, how much memory does my application use, how many CPU cycles my application use. Okay? So this is the fundamental of the serverless, basic tenet on which the serverless architecture is standing. Right? You can always say that, oh no, I don't have to worry about cost model. everything is, I'm already on cloud. I already do shared resources. My VMs are always utilized. There was AWS recently said that they saved, by helping customer move to the cloud, they saved close to $500 million for a customer. Right? I feel bad for those customers who paid $500 million extra. They could have given hike to all the employees. Right? In fact, because of the pressure of this, most of the cloud services, they're coming up with a utility which you run. If you run that utility, it will tell you how much capacity is underutilized. So for example, Azure comes with something called Azure Advisory. So if you log into the Azure portal, you will actually see which of the VM was never used. It happens, right? You start a VM, after people move out, something happens, that VM must be running happily somewhere. Nobody knows about that VM. Must have happened to most of us who have been in cloud world. We started a VM, forget about it. But still you are paying for it. The amount is so minuscule. If you're paying like $500,000, $5,000 here and there, doesn't matter. It matters to me if they pay me, but to the company it doesn't matter. So even in the cloud, there is so much of the wastage that you don't realize. So even though Azure and AWS, they are coming up with an advisory, they are coming up with the tools which tells you what is not used, but this tells you upfront. In fact, there are calculators available. You will see it down. There are calculators available through which you can anticipate the price, how much it is going to cost. Okay? So there are a lot of advantages to that. The first is, it is good for application architecture. It is not good for not good for enterprise architectures. When I say application architecture, you are building a part of the enterprise. Right? For example, a small thing that you are building. In our demo, we will see that if you have to crop an image, or you have to build, cropping an image is a big use case. If you are building any application, in a major internet application, right? It is good for building rapid prototypes. How many of you plan to build an app in near future, or plan to build a company in near future? Okay. So this is a very good example. No string attached, nothing to do, means all of us talk about lean startup and all those things. This helps you in enabling the lean startup. So event-driven architecture. Event-driven architecture is, an email comes, you want to act on that email. You read the content of the email and then figure out, you apply for a leave. Mail goes to somebody, that person is on leave, that mail has to be routed to somebody, right? So you can write a simple trigger, find all the employees who are on leave, check their mailboxes. If somebody has applied for leave, somebody has applied for leave and route the request. So it's more event driven. You will see how, if an image is uploaded, you want to act on that image. If a document is uploaded, you want to capture, if a PDF is uploaded, you want to do OCR on that image, on that PDF, and save it in an index, save it in a database and then index it later. Okay? Especially in Azure world, it is integrated with many services. So how many of you here use Azure extensively? Or AWS? Okay. So, AWS provides, or Azure provides so many services. You have storage service, you have compute service, you have event hub, you have messaging service, brokers, and there are multiple types of storage. So it can integrate with all of them, or many of them. It can integrate and it can process data in some of them. It has visibility to expenses, payment tied to the usage, and most importantly, especially in Azure world, it has a strong product roadmap. The CEO has covered it recently. In fact, Microsoft is saying that we are not going to focus so much on mobility. We will focus on machine learning, cognitive, and serverless architecture. So all of that goes to show that it's a strong roadmap. Everything has 0 and 1, so there is a 0 part of it. It has some disadvantages. The first thing is vendor login. How many of you have written stored procedures in their life? Many of you, right? Why? What was the biggest disadvantage? Vendor login, you cannot come out of it, right? In fact, if you go to the cloud, you can move your infrastructure, not very difficult. There are so many utilities available. You can even move your storage, right? This is something, it's an application, very difficult to move out, because that's where the logic is. So before you plan to lock it into the vendor, you have to do due diligence, and there is no other option but to, if you move there, you will be locked in. This provides a great opportunity to a lot of you. In case you want to write an abstraction layer, you want to start a company, you can start a company which all does is write a function, you execute anywhere. Okay? Support for debugging. If you are accustomed to Eclipse or Visual Studio, doing a remote debugging, it is not possible here. It's coming up, you can debug it, but it's not as intuitive. Functions cannot call functions directly. Kind of bad, right? Yeah, but that's the reality. In Azure, you cannot call functions.
In AWS.
Yeah, AWS is pioneer, okay, so I know AWS you can do a lot of things, Azure you cannot do that. Maybe it will come, Azure is catching up, it will come. Difficult to share common classes. Maybe I don't know how it works in AWS, but in functions, if you have one class that will be shared between two functions, you might have to copy paste the function classes there and there.
Same thing in AWS.
Same thing in AWS. And the biggest disadvantage, not a disadvantage, but kind of, it is not meant for long executing functions. If you have like 10 seconds, people say 10 seconds, I would say even if it is like more than 2 seconds, it is not worth it because the cost increases and it's not meant for that. So let's go only in the Azure functions.
Can I add 2 points to the previous thing?
Yeah, sure.
One other issue is when I am writing my function, depending on a lot of services, the issue what I am talking about is the integration issue. So when I build my application, depending on Auth0, so many services, right? So I depend on version 1 of the service, version 2 of the service. When I am in production, right? So I cannot really have control over all the services. They can automatically upgrade their own versions.
So you're saying versioning is not supported?
Versioning, like when I own my application, it's difficult for me to ensure that it always works. So when these vendors upgrade their own services, I need to again go and retest everything, ensure that my application works with the latest version of all of these services.
Yeah, so that's a good point, but that's something that you have to build it into your application that you are building. Most of the time you have to target it against a particular version of, for example, if you are using SendGrid for sending email, then SendGrid has a proper versioning and you have to go against V2, V1, V2 or V3. So I'm pretty sure if a company has a strong roadmap, they will not change it.
So that is one area that people who are going to adapt.
Definitely.
That's an open area for opportunity.
Yeah, if there is a bug in V2, you have to upgrade to V3. Yeah, definitely, that's a problem.
And so we talked a lot about cost, right? Again, yes. So it gives the pay for the per execution. At the same time, it assumes that your person who is writing the code is well architected and it's thoroughly reviewed and implemented.
Yeah.
So
definitely.
accidentally, if you have a reflection function and it keeps calling function, right? The 10 minutes, whatever the 34 users we used, if that website has made a unlimited call to S3, pull everything, even the 10 minutes could have resulted in $1,000 budget.
Yeah, definitely. I think that holds good for any application that you are building. Right? For example, you have to be worried about recursion, and you have to worry. Code has to be well crafted. Right? So that's something. Definitely.
So compared to VPS, my own VM, I pay $20 a month, so I'm covered. So I just wanted to caution people that there's a lot of hype and ensure that you carefully decide when to choose serverless, when to go with your traditional cloud approach.
Yeah,
So to
definitely.
add to that, right, cloud is costly over a period of time. Yes, it gives you a good entry point, but in the long run, if you are planning, cloud is costly.
Okay, that's opening a Pandora box. That's a good opinion. Yes, again 0 and 1, there are no perfect answer in our world, right? For some use cases, definitely cloud is very costly, and some use cases, it is not, you don't have to pay that much. Yeah. If you're making a movie like Bahubali and you need servers, then cost is, you don't want to go to AWS, right? But if you're writing CRUD applications and the focus is on solving a customer need, then yes. Okay, so this is just whatever we have discussed. So you have Azure functions and services. Azure provide a lot of services. You have GitHub. I should have put it outside this triggers. But yeah, you have triggers on one side. You have bindings on another side. You have Azure storage, events hub, Cosmos DB scheduler. Any of them can invoke Azure function. And once you invoke it, Azure function can talk to any of these. There are more. You have to probably go through the document, but this is at high level, this is what you can do. And again, node function cannot call function, which cannot call function. Right? Means the pattern to implement that is you use a broker, message broker in between, function rise to the broker, and then it gets broadcasted to another function.
Why do you have this limitation? Why is this limitation there?
Why there is a limitation? I think that because the product is still evolving, so it will come out.
I would also say it's a feature, it's not a limitation. The distributed functions by definition should be independent, they should just work on their own. If they need to talk to each other, together they are one function. So we are trying to get away from monolithic to microservices to, let's call this nano services. So they are supposed to be independent.
But can they interact with the API?
Yeah, of course.
Yeah.
Of course, they can interact with each other based
Yes, so when I say function cannot call function means in a traditional world you just want to.
it cannot be a binary call.
Yes.
Yeah.
But you can still talk to events.
Yeah. You can, for example, you can use a message broker, you can write to there, and then it can pick it up from there. Functions, you can expose it as an HTTP trigger, you can then call it through HTTP triggers, right? So, that's what it is. But yeah, the thing is, when they started, they wanted to basically implement a single responsibility pattern, right? One thing does it pretty well. But yeah, it is evolving. AWS saw it coming, AWS thought that, people are building applications around it. Most of the applications, a lot of applications are built around it. In fact, some people say 20% of the new applications that are built in AWS, they are already using this. And there was a, I would say push from the developers who said that it should call. So AWS started supporting it, maybe Azure will support it in the future. Okay, cost model. Okay, so is it visible? Okay, so how does it work? How the costing is done? The top three line. So what it does is it says that memory usage, how much this application, you build a nice application, you're ready to deploy it in Azure and you want to see upfront how much it's going to cost. So it depends on three factors. Memory usage, how much memory it's going to use, which is very easy to calculate, right? You can run it locally and see how much memory it's going to use. Number of executions, right? If you're on IRCTC site, kind of site, I will get millions of users, or if you're building a small application, you can predict a little bit, okay? And duration, how long my functions run? 1 second, right? And based on that, so what Azure provided, what it comes is GB per second. How much real byte of memory will be used per second? Okay? So which is very easy to come up with. You have 1536 memory divided by 2048 and then you multiply by this, you come up with this. This is the amount of, the GPS what they call it, it is there. Now, Azure know that there is no way for you to run the method functions locally, so it provides a lot of free grant. How much free grant does it provide? This much, 400,000. So you can call your function 400,000, first 400,000 in a month are not charged. Kind of cool if you are a good programmer, not too good if you like to iterate multiple times every line of code you want to check, then it's not a good. So chargeable is this much, 2.6 million. Okay. Now, for this you have to pay this. I don't know how to do it because it's on a decimal side. There are a lot of zeros and then 1 6. So one execution will charge that much. Okay? And then this is the consumption. This is the consumption for this much GB usage. Okay? Now you are calling it 1 million times, then the chargeable is $0.2 per million. So $0.2 per million of execution what they charge. So you come up with this number and you just add both of them, 41.8 and 0.2. So this is the number that you come up with. So what you can do is if you increase the number of duration, your cost will probably double. Okay? So remember, the one thing to note here is it does not charge.
Can you put 10 here, 10 there just for fun?
Huh?
Can you put 10 there instead of 2?
Yeah, sure. Yeah, obviously if it's a long running process, then it's going to charge a lot more. So the important point to note is that you have to don't want to write a very CPU intensive application which runs for a long time. It beats the purpose and there is no mechanism to poll, then you have to do a lot of polling. In fact, long running processes in a web application is a kind of anti-pattern. Right? So you don't want to do that anyway.
These are the function pricing, right? The per function pricing?
Huh?
These are per function pricing?
No. You can have 100 of function and this is how it is going to charge, then this is how it will come out. Doesn't matter. It's not like per function. If you have 100 functions deployed, but collectively they use this much memory, they are called this many times and they use 10 seconds, then probably will come up with this.
What are the use cases that you should consider for?
Okay.
What are the use cases that you should consider for the serverless architecture?
Depends on the domain. It's basically I would say everything that's a short run, that execute faster, which is atomic. You're writing a microservice, right? And I would say a rule of thumb, a microservice which get executed under 1 second can be implemented with a couple of functions. You can do that. Again, means if you are.
So in Azure you have web jobs.
Yes.
So which is basically the underlying model for.
Yes, it's yes.
So in case I have to choose between the two, what's the guidance? Is there any guidance? Like, how do I choose? I can do the same stuff in a Azure web job.
Yes.
And I can do the same stuff in the functions also.
Definitely.
Anything which can make the choice very clear that okay, this is the case, then we'll go for this, or else we'll go for that.
See, we are not. we have never used web jobs. What we have probably used is we have used something called Azure Service Fabric. So in Azure Service Fabric, it's something which you use microservices for. So what happens is that if I have to compare with that, as I said, if it's a short running process which is a single responsibility pattern and you can implement it one function, then probably you want to use that.
Yeah, the difference is cost. Web jobs are always running, and whether they're doing something or not, you're always paying for it.
No, actually,
Functions are, web jobs are running on an existing app services,
Yes.
existing, let's call them VMs. They're running on your existing infrastructure, and for which you're already paying.
Yes.
So, and it's there all the time. This is, nothing is there all the time. It's when you invoke it, then.
So it's kind of ephemeral, what they call it, functions are ephemeral. If you don't use it for like
15 minutes is
something like that, right? It depends on which VM they are running and things like that. If you don't use it, then maybe they will go in a hibernate mode.
But if you already have an app service plan, which you have already
Yeah, if you already have an app service plan and if you already have capacity in your web services to handle also the jobs, sure, you can run it there and you don't have to pay anything extra. But then the other part you lose is triggers. With Azure Functions, all the triggers are already there. If you write your own web job, you have to program for those triggers.
No. That's where it gets confusing.
And to make it even more confusing, you can even run Azure Functions within your app service plans, which means
I did not want to confuse the audience. Just for the sake of simplicity, I focus more on the consumption plan. Then
I think it's good to say because this is something different on Azure than Lambda or AWS.
Yes.
Because on AWS, functions are pure in their purest form. That you call them, you pay for execution. How many times you call, you pay based on that. It doesn't matter where the functions are running, you don't know where they are running. Okay? And same thing happens on Azure also. But Azure using another option, if you are already using other Azure services, like you are hosting a website already on an Azure VM, it's called an app service, that's the technical name for it, but it doesn't matter. If you already have that, and if you think that VM is not optimally used, you can tell Azure, run my functions over there. And when you do that, there is no charge because you are already paying for the existing, VM. So, of course, that means you cannot run infinite. You cannot run like 10 billion calls. You are running in your existing plan, right? Existing infrastructure. So, it will try, of course. It will try to run as many as it can, and then after.
Maybe the auto scaling is then
Sure, you can also set auto scaling, but then you pay for how much you use. So that's fine.
Yeah, what Microsoft did was they built it on top of web jobs. In AWS, they built it on top of containers. So this is more of this strategy seems like a reaction to what AWS has done. Maybe it will change over a period of time. Even when you run it, the kind of exceptions that you get, it tells you that it is running on top of a web job. And to answer your question is, this also you can make it always on. So there are options available, you can keep it on. So you can make it always running.
And the web job also you can make it like it can.
Yeah, other way around. You can stop.
That's where the confusion is. But I guess.
Okay, so.
Yeah, I think it's a separate topic of discussion. Azure provides so many options to build an application. You have logic apps, you have web jobs, you have service fabric, and now you have other function. So what they are hoping is that based on the usage, they will start promoting one of them.
So if I have a microservice, I can post it on a container or I can post it on a serverless. How would I do? When will I do what?
Come again?
If I have a microservice, I'm trying to post a microservice.
Yes.
Today I have an option of posting it in a container, a Docker container, posting it from other containers, or I could push it on a serverless as a serverless application. Whatever code, whatever business logic I'm running, right? How do I make a decision where I should post it?
I'll expand that question and make it more confusing. You can also host it in Service Fabric, which is a Uber container in.
No, I don't want to. I want to just get to
Yeah.
then expand beyond.
Yeah, see, again, Docker is more at the infrastructure level to me. So the way I think is it's more of an infrastructure function is more abstracted. In Docker, we don't have, here I have, whatever time I've covered, I have not talked about the images and all. How to build Docker. So there is CI/CD associated with the Docker. You write an application, then you have to create an image, you probably have to start a Jenkins, you have to write a bunch of scripts. If you're okay with that, you can go ahead with that. Functions, it's a highest level of abstraction. You have an idea in mind, you just want to write a calculator, you write a calculator. You want to create a checkout function.
No, what you are saying is from a developer perspective, what all he has to do.
Yeah.
Let's say I'm in business, I pay money at both places, right? From that perspective, it doesn't matter, the developer work or less work. Because here, debugging is difficult, here maybe something else is difficult, right?
Yes.
So here, that's why I pay him and he gets the job. So I'm looking at more, keep that aside, the amount of work involved, which is going to be the best for me to post my.
I would say if you have less than, if you can quantify the amount of the time the method takes to execute, then Azure function is the thing. You can integrate with GitHub, you can deploy directly from GitHub to Azure functions, and you will be done with it. Since you said you are a business, then this makes more sense. You can talk, when you go to the developers, you will tell, I want this function, they will develop it. They will be able to develop without throwing that I have to do Jenkins, I have to do Docker, and things like that. Right? So maybe what you can do is you can expose your microservices with this, low-level microservices with this. On top of it, you can write a composite web service, maybe in Docker, Service Fabric or something, which expose a composite web service, which is exposed to the client. If you're writing a single page application, right, then you can write it with this, and the single page application may component calls to the functions through HTTP trigger, and it will be taken care of.
So you are seeing both of them coexist. Thanks.
Depend on the use case.
No, you're looking at a use case which is inclusive of both.
Yes. Yeah. So there is what people are calling it a hybrid approach to developing microservices. Okay, let's look at the demo. It probably will answer some of the question. What we are going to look into the demo is that we will store something in Azure storage. When we store something in Azure, we will store an image in the Azure storage. That image is created by the Azure function. We will use Microsoft Cognitive Services for creating a crop, for cropping the image. The only difference here is when you crop an image, it is important that you crop the image at the point of interest. So if I'm taking a photograph of this and it's a big photo, and if the person is standing on the right side of the image, you want to make sure the right side is cropped, not the center part. It will miss the cropped image will miss the point. So what Cognitive Service provides is it provides you a smart crop. It keeps focus on the point of interest, as they call it. And then we'll proceed this image back into the Azure storage, and then we will use application insight to monitor the usage of my functions. Okay? How many of you think how much time will it take to implement this? Means in a traditional way.
It should be within 5 minutes.
It will execute within 5 minutes. It will execute within 5 minutes. Okay? having hard time reading this. Okay, so this is my in storage. This is where I'm going to upload my image. And once I upload my image, then a crop version will come up here in the out folder, in the out container. Okay. I'll upload. Start with one. Okay, I have uploaded it. It will take. Now this is my function. It gets triggered. Okay, so you have a trigger point, you have an input and you have an output. Very simple. Trigger it, you specify the name of the function. Output you specify where you want to put it in the Azure storage. Okay, so there are like a couple of configurations that I have done. I have specified the path, I have specified the storage location. Here again I have specified the output storage location, the path of the block and the output storage. And this is my monitoring. This is pretty cool thing. You can actually see how many methods and how many times this is getting invoked, how long will it get invoked and things like that. So I think this is the one I uploaded. Okay, it got uploaded here and you know what was the name of the image and things like that. You go here, if I open this image, okay. This was roughly.
That is input image.
Huh?
What you're opening is input. That is the input folder.
Really?
You should look at
Oh, sorry. I'm having a hard time reading this. Okay, so you can see that it was close to 800 MB and KB and then it became 2.2 KB. And so this is, I think it doesn't look good on this projector, but this is how it looks like. Okay? When you crop it, if you go back, and it got implemented in close to 30 lines. Means no glue code, nothing. Took it from the Azure storage, did some, it made a call. I don't know if it is visible, but the cognitive service which actually does the image cropping, it's just a call. It's an HTTP call. Basically you can say it's running a machine learning behind it because it does an image recognition, finds out which is the important part of the image and crop only that part. And then it writes it back here. If you want to send email, you can also integrate with SendGrid. So what you have to do is you have to go here. You can write a new output. So when you are writing a new output, means you just see the number of options that are available. And somewhere here there is an option for SendGrid. So SendGrid is a service. Again, it's a email as a service you can say, or mail sending is a service. You can integrate with SendGrid and it will send an email. So so in our use case, we are building an application, we are building a catalog, and our customers upload thousands of images. So once they upload the image, it goes in the storage account, and we have to run this function. And then it has to give a smart crop and put it in another container. And then it can send an email whenever all the jobs are done, you will get an email. Okay? Okay. That's about the demo. Thank you. Yeah.
Crop as a function.
It's not a crop as a function. It's it's a Microsoft cognitive service. It takes an image. You can pass the image through an HTTP service.
When we talk about the AWS Lambda function or Azure function, so I come from a C++ background, writing functions and so. What kind of functions? How they decide which functions is required and how it can be a kind of a pluggable or framework kind of thing where any users from any domain can use it. So crop is it a kind of function? If I would have
It's a service. So you can say, you see, in our demo we had two containers. Okay, one from where we were picking the image, another where we were putting the image, and this is another service which is provided by Microsoft. So I have to pass the image to that service and get back the image. Okay, so basically function here was acting as a classic glue code. Okay.
So it costs you for the external services which you are using, or it's a part of?
Come again?
Yeah, it costs. Microsoft Cognitive Services is a separate API.
Yeah.
Of course, you get some free usage, but that's a separate API. You pay by times you call.
Yeah, most of the API costs that you have, they are close to 100,000. I think they are like 40,000. First 40,000 calls are free in a month. You can also do text to PDF to text. You can also you can pass a video and get the snapshots of the video. There are a lot of services that are available. You can also pass an image and see whether what kind of animal is there. Okay, thank you.